All right, and so then let's see what we did here. What do we do with this one? Plug in the -2, right? This is just a substitution problem, okay? When I'm saying f at -2, I'm just saying let x equal -2 and substitute it in. So f at -2 is equal to 6 minus -2 quantity squared. Do my negatives cancel? You do your exponents first, right? Please excuse my dear Aunt Sally. Remember that from algebra? So what is -2 squared? So this is saying 6 minus 4, right, which is 2. Is this a fraction here? 5 over? Okay. All right, find f of m if f of x is equal to 5 over 2 minus x. I'm just letting my x be what? Okay, so when I substitute it in, that's 5 over 2 minus m. Is there anything to simplify? No, that's just what it's supposed to be. Okay, this one is the square root of x squared minus 4. But I want to figure out what f at 3a is. So for x, I'm going to plug in 3a. So I'm going to take that 3a and I'm going to square it, and then I'm going to subtract the 4. And so under the square root, I'm going to get -4. So can I say that that's the same thing as 3a minus 2? Can I take the square root of 9a squared and take the square root of 4? No. I can't simplify and separate that square root because of the subtraction sign that's inside. Okay? This does not mean the same thing as the square root of 9a squared minus the square root of 4, so don't make that mistake. We've got to have products going on inside. We've got to have the same thing multiplied twice. Yeah, I mean, this is the same thing as 3a plus 2 and 3a minus 2 under the square root. Right? Isn't that what this is? And if I want to be able to pull anything out, it's got to appear twice as a factor. Better? Okay. Okay, so let's just kind of review. You had this last year in Algebra 2. We're going to talk about these domains. These are just dealing with functions. Okay, what are we doing with these two functions? In this case, I'm going to add the functions together. F plus g. This is, do you have the same? So this is telling me take my two functions at x and add them together. No, this is saying f of x plus g at x. X is my independent variable for both of those two functions. What am I going to do with those two functions? I'm going to add them together. Okay? So then the next one is saying really f of x minus g of x, so I'm subtracting the two functions. This is supposed to be a dot, not a little star. So what am I supposed to do with these two functions? Multiply, right? I take f of x and times it by g of x. So I'm multiplying. Okay, and the last one shows division. Which one goes up top? F of x. So f of x over g of x. We got division. All good? Okay. Do you remember doing this from last year? Okay, we talked about domains and ranges also, if you remember that. All right, we'll talk about that in a minute. What am I supposed to do with my two functions? All right, so I'm going to take 2x minus 1, and I'm going to add x squared. Okay, so look, this is f of x, right? It's just telling me my independent variable for each of those is x. It's defining what the independent variable for each function is. And it doesn't move. It stays on that left side. So don't try and divide through by it. All right, it just stays there. It's how we define that or name that. Okay, so 2x minus 1 plus x squared. Don't have to worry about any negative signs that we have to pull through. Reorder it. Look for common terms. Do I have any common terms? No, I've got an x and an x squared. They're not like terms. And so we get x squared plus 2x minus 1. You don't have to. You could if you wanted to. But I don't think that one would factor. Product that gives you -1, but the sum that gives you plus, so that wouldn't. All right, so here I'm going to subtract the two functions. Which one goes first, the g function or the f function? The f, all right? So I'm going to get 2x minus 1 minus x squared. And the order does kind of matter when you're subtracting and adding. And so I'm going to get 2x squared minus 1 minus x squared without my parentheses. And when I reorder it from smallest to largest, that's what I get. Are we good? And this last one, or this next one, what am I doing? Okay, so I'm going to take 2x minus 1 times x squared. We do want to work this out, so what am I going to do? Distribute. So 2x times x squared is, and -1 times x squared is. Yep, and I'm done. And the last one shows division. So 2x minus 1 over x squared. And so do the x's cancel? Is that a common factor? No, it's got to appear in every single part of every single term. Okay? So while these both have x's, this -1 up here doesn't. So it's not a factor. I'm subtracting it, so I can't reduce it any further. Yes? Then you could pull out an x from every term up top and reduce it with the x squared down below. Yeah. So if I had this, let's say I had this, right? I'm going to pull out an x here and be left with 2x minus 1 over x squared. And remember, you're reducing factors, things that you multiply. So this x is being multiplied by the 2x minus 1, right? So it would be able to be reduced. Okay? We talked about this a lot last year in my class. All right, compositions. You got this little circle. And what that's telling you to do, if you read from right to left, is put the g function into the f function, or the f of x. Okay? So I want, into my f function, I want my g function. What's my g function? So I'm substituting in 3x into the f function. So my f function is right here. So wherever there's an x, what am I going to input? Okay. So 3x squared minus 1 is the substitution. Agreed? And 3x quantity squared is what? 9x squared minus 1. And that's what f composition g of x, or fog, or f of g of x. You good? And when we do it the other way, into the g function goes my f function. Remember, you're working from inside out or from right to left. And so into the g function, we're going to multiply 3 by x squared minus 1. And we want to simplify it out, so we'll get 3x squared minus 3. And when I put a function into itself, this is called an iteration. When you substitute a function into itself. These pictures right here, these are all mathematical iterations. There is a function, and it keeps repeating and repeating and repeating. And there are some very famous iterations out there. So when I do f of x, I'm plugging into f of x, x squared minus 1. Agreed? And so I'm going to put x squared minus 1 squared, and then minus 1. So am I going to distribute that squared value? No, because I'm squaring this whole term. So it's x squared minus 1 times x squared minus 1 minus 1. We get x to the 4th minus 2x squared plus 1 minus 1, which is just x to the 4th minus 2x squared. Are we good? Anybody got a question? Okay. All right, so now we need to look at the domains and the ranges. So remember, domains, you're worried with square roots. They have to be greater than or equal to 0. And you're worried about denominators because they can't equal 0. Those are the only two places where you have to worry about the domain. So when you're doing compositions, you worry about the function you are substituting into and you worry about final function. And I'll tell you what I'm talking about. Okay, so f of x is equal to the square root of x minus 3. G of x is equal to x squared. I want to know what the domain of f or g of f of x. So I'm looking at this. This is golf this time. I'm putting my f function into my g. Oh, did I skip one? Sorry. Well, you want to do this one first? Sorry. I did. So this is saying f of g of x, correct? Agreed? G goes into the f function. G goes into the f function. Here, f goes into the g function. Working right to left, inside to outside. So we are worried. If you look at the domain of just f of x, you're trying to figure out what the final domain of this final composition is. And then you look at the domain of the composition. So your final answer after you've done your substitution. And you put those two domains together. F of g of x. That's called a composition. look at the domain of f of x, what's my domain of f of x have to be? You have to set it, right? X minus 3 is greater than or equal to 0. So this domain is that x is greater than or equal to 3. Would you agree? Okay? All right, now we're going to do this problem. That means into my f function, I'm putting x squared. That's what my f of g of x is, correct? Okay, and that means I'm going to put in under the square root x squared minus 3. So now I need to worry about x is greater than or equal to 3, and I have to see now what my domain for this is going to be, correct? All right, this is similar to something that you did on your review sheet. It's a square root again, correct? So now x squared minus 3 has to be greater than or equal to 0. So we're looking right now at plus and minus root 3. So we did test values, negative 3 and 3 under the root. And here's 0. If I were to plug in 0, would I get a true statement? Is 0 minus 3 positive? No. So do I want anything in between these 2 points of interest? No. That means probably I'm going out this way and this way. So we could try, for example, 2. 2 squared is 4, correct? 4 minus 1 is 3. 4 minus 3 is 1. 1 is positive. Agreed? If we try negative 2, negative 2 squared is 4. 4 minus 3 is. So do you see that the solutions that make that square root positive are out from the root 3? It's an OR statement. Okay. All right, so when we put these two domains together, I want x is greater than or equal to 3, and I also want that. Well, we're going to go ahead and say less than or equal to negative square roots of 3. But we have to satisfy both greater than 3 and greater than square root of 3. So where is the overlap going to happen? Here's square roots of 3. Here's 3. Where, at what point is your solution going to work for both of those domains? Greater than 3. So x is going to be greater than or equal to 3. That becomes your domain. Because this one works for the left side, it's the right side that we have to worry about. All right, try g at f of x. You do the substitute. You can find the domain for the individuals. So into the g function, what am I putting? Yeah. Hold on. And so that's just equal to x minus 3, correct? So what was your g of x domain? Okay, because I don't have a square root and I don't have a denominator, correct? What is my answer's domain? My answer is x minus 3, correct? Do I have a square root? Do I have a denominator? So my domain is going to be all reals. So when I look at the domain for both of those, what is my domain going to be? All reals, right? So here is my answer, and your domain is going to be x as an element of the reals. That one was an easier one to deal with. If you have a denominator, you set it equal to 0. No, because it's like saying y equals. I'm not trying to find a solution. All right. So if we wanted to do this, what would our domain be for this one, just for f of x? So do you have a denominator or a square root, Helene? So what do we know about the denominator? What don't we ever want in the denominator? No? What value do you never want in the denominator? 0. So denominators can't equal 0. So what value would you put in here that would make it 0? 1. So our domain is x cannot equal 1. Sure, well, but even if we put in 1, 1 minus 1 is 0. 0 squared is? Okay, what's this domain? Do I have a square root? Do I have a denominator? So it's all reals, right? You just have to look at those two places, okay? All right, so which function is getting inserted into the other? So we're saying f at x plus 3. That's what that's saying, correct? And so that means we're going to put 1 over, and we're not going to write x, we're going to write x plus 3, and then minus 1 squared. So that's 1 over x plus 2 squared. What would the domain of this be? Of your answer? Can't equal negative 2, because that's what gives me 0 in my answer, right? So my overall domain, we've got to put our domains together. We have to put together the f of x, which is what we put it into, and our answer, which is what we get. So what is our domain? X can't equal what? 4 or negative 2. Does that make sense? Can't equal both of those values. It didn't work in my f function, so it's still not going to work. And what we also find at the end is that negative 2 doesn't work.
Can you check these?
How would you check them? Can't check them. No. All right, so the composition of a function with itself is an iteration. So here, find the first 3 iterates, x1, x2, x3. If I give you the function is 3x plus 2 and x sub 0 is 4. So x sub 0 is 4. So remember, an iteration is putting the answer back into itself. So x sub 1 is going to be, what am I going to let x be? What am I going to be putting back into itself? 4. We're going to put 4 in because that's what we got at the very beginning. So we're going to say 3 times 4 plus 2, which is 14. What's x sub 2 going to be? What am I going to put now in for x? 3 times 14 plus 2 is 54. I have to do 3 times. What's x sub 3 going to be? 3 times 54 plus 2. Because I keep putting it into that 3x plus 2. I'm just taking my answer and putting it in. Taking that answer, putting it back in. And so what is that? 152, 162, 164, if my math's right. Huh? It's the answer that we got the previous time. So I'm starting you with what one of the first answer is. It's 4. So to get x sub 1, I'm plugging in 4 and getting 14 and putting it back in 14 and getting 54 and putting it back in to the next time and getting 164. Okay? All right, so I don't give a whole lot of extra credit. So find a name of a common mathematical iteration, print it out with a picture. Should all have different ones. All right? Bring it to class on Wednesday. And that'll be a homework bonus. Joke?